Sand. It's everywhere. On beaches, in deserts, even in our back gardens. We think of it as commonplace, unremarkable. But hidden within these tiny grains is the potential for something extraordinary. Glass. Yes, glass, that ubiquitous material we hardly notice, begins its life as ordinary sand. The transformation is remarkable. Intense heat, over 1,500 degrees Celsius, is needed to melt the sand. It becomes a glowing, molten liquid, a miniature version of volcanic lava. This molten state is where the magic happens. It's where sand loses its granular identity and takes on a new life. The result? A substance that is both beautiful and incredibly versatile. This process, mastered over millennia, is how we get from ubiquitous sand to the glass that surrounds us. Transforming sand into glass requires more than just heat. It's a carefully orchestrated chemical dance. Each ingredient plays a crucial role, altering the properties of the final product. First, we need something to lower the melting point of sand. This is where soda ash comes in, making the whole process more manageable. Without it, we'd need the heat of a volcano. Next, we add limestone. This acts as a stabilizer, ensuring the glass doesn't crumble as easily. But the real magic lies in the additional ingredients. Want a beautiful emerald green? Add a touch of copper oxide, a deep, rich blue. Cobalt oxide is your answer. The possibilities are almost endless, limited only by our understanding of chemistry and imagination. Once we have our molten mix, the real artistry begins. The molten glass, glowing with intense heat, is carefully gathered on the end of a blowpipe. The glass blower, with practiced skill, begins to shape the molten blob. Air blown through the pipe creates a bubble, which is then manipulated and shaped. It's a delicate dance between heat and cold, a constant battle against gravity's pull. As the glass cools, it becomes more viscous, harder to work with. The glass blower must work quickly, their movements precise and deliberate. Unlike most solids, glass doesn't have a regular, repeating crystalline structure. This unique structure gives glass its remarkable properties. It is this amorphous nature that makes glass so fascinating, so versatile, and so essential to our modern world. Why is glass transparent? It seems like a simple question, but the answer lies deep within the atomic structure of this fascinating material. Most solids absorb light, which is why we see them as having color. But glass is different. Its unique structure allows light to pass through it with very little absorption. It's like a window for light waves. Some light is still reflected, which is why we can see our reflections in a mirror. This transparency, so easily taken for granted, is what makes glass so valuable. It's a reminder that even the most familiar things can hold hidden wonders. Glass is more than just windows and drinking glasses. It plays a vital role in countless industries, none more so than science. In the laboratory, glass is an indispensable tool. Its transparency allows scientists to observe reactions and experiments with clarity. Its resistance to heat makes it ideal for handling high temperatures and corrosive chemicals. Think of beakers and flasks, test tubes and pipettes, all essential tools made from glass. Highly specialized glass, like Pyrex, can withstand extreme temperature changes without shattering. The invention of the microscope and telescope, both reliant on lenses made from glass, revolutionized our understanding of the microscopic world and the vastness of the universe. These instruments, extensions of our own senses, wouldn't be possible without this remarkable material. Glass, often associated with fragility, can also be a shield, a protector against the elements and even violence. Its strength, often underestimated, is crucial in applications where safety is paramount. Consider the windshield of a car. This seemingly fragile sheet of glass is designed to withstand tremendous force, protecting passengers from debris and impacts. Then there's bulletproof glass, a layered composite of glass and polycarbonate. This remarkable material can stop bullets in their tracks, absorbing and dissipating the energy of the impact. Fire-resistant glass, used in buildings and public spaces, can withstand intense heat, preventing the spread of flames and smoke. It buys precious time for evacuation and can be the difference between life and death. Step into a modern city, and you are surrounded by glass. Skyscrapers reach for the sky, their glass facades reflecting the sun and clouds. Homes feature expansive windows, blurring the lines between inside and out. Glass is no longer just a material, it's a design element, transforming how we experience our built environment. In architecture, glass is prized for its ability to bring in natural light, reducing the need for artificial illumination. This not only saves energy, but also creates a sense of openness and connection with the outdoors. But glass is more than just windows. It can be used for walls, floors, even staircases. Its versatility allows architects to create stunning visual effects, playing with transparency, reflection, and light. Think of glass bridges that seem to float in mid-air, or glass floors that give you a dizzying view of the world below. Stained glass windows transform sunlight into a kaleidoscope of colors. We live in an age of instant information. Data zips across continents in milliseconds, connecting us in ways unimaginable just a few decades ago. And at the heart of this revolution is a thin strand of glass, the optical fiber. These hair-thin strands of glass, incredibly pure and flexible, can transmit light over vast distances with minimal loss. Information, encoded as pulses of light, travels at incredible speeds, forming the backbone of our modern communication networks. Consider the internet, a vast web of information accessible at our fingertips. Without fiber optics, this global network wouldn't exist. Every email sent, every website visited, every video streamed relies on the magic of light guided by glass. They are used in medical imaging, allowing doctors to see inside the human body without invasive surgery. The possibilities, like the strands of glass themselves, seem endless. From our earliest days, humans have looked up at the night sky, filled with awe and wonder. And for centuries, we have relied on glass to bring the cosmos closer, to unravel the mysteries of the universe. The telescope, arguably the most important scientific instrument ever invented, relies on lenses and mirrors made from glass. These carefully crafted pieces of glass gather and focus light from distant stars and galaxies, allowing us to see objects billions of light years away. From Galileo's first observations of Jupiter's moons to the Hubble Space Telescope's breathtaking images of distant nebulae, glass has been our window to the cosmos. It has revolutionized our understanding of the universe and our place within it. Observatory domes, often massive structures, are designed with glass in mind. These domes, beacons of scientific exploration, stand as a testament to the enduring partnership between glass and our quest to understand the universe. Glass, in its many forms, has been intertwined with human civilization for millennia. From the first crude beads and vessels to the sophisticated fiber optics and telescopes of today, it has shaped our history, our technology, and even our art. Think of the stained glass windows of medieval cathedrals, transforming sunlight into a symphony of color. These masterpieces of craftsmanship, still inspiring awe centuries later, are a testament to the enduring beauty and artistic potential of glass. Or consider the humble drinking glass, an object found in homes around the world. Its transparency, its smooth feel, the way it refracts light, these simple pleasures connect us to the material and its history. Glass, in its various forms, reflects our own ingenuity and creativity. Ordinary glass is impressive on its own, heat-resistant, chemically durable, and optically transparent. But what if I told you that by adding specific chemicals, we can enhance these properties even further? Enter glass modifiers like lithium oxide, calcium oxide, and zinc oxide. These modifiers are added in small quantities to tweak the glass properties. For example, adding lithium or calcium can lower the melting point and viscosity, making the glass easier to shape. On the flip side, these chemicals also create non-bridging oxygens, interrupting normal bonds and changing the glass structure. Let's break it down. Alkali metals like sodium and potassium can reduce the chemical durability of glass, making it less resistant to wear and tear. Meanwhile, alkaline earth metals like calcium can actually boost its durability. In electronics, high-resistivity glass is useful for resistors and capacitors. Adding oxides like tellurium or germanium can increase resistivity, perfect for high-resistance applications like hearing aids or infrared detectors. In labware, glass with strong chemical durability and thermal shock resistance is crucial. Borosilicate glass, which includes borate as a network former, excels here. It's commonly used for reaction vessels and test tubes. And did you know about bioactive glass? This modified glass closely mimics the mineral portion of living bone, making it perfect for medical implants. Comprising around 45% silicate with calcium and sodium, it's soft and machinable for repairing bone injuries. So next time you look at a piece of glass, remember, it's more than meets the eye. As we look to the future, glass will continue to play a vital role in addressing global challenges and shaping our world. Its versatility, combined with ongoing innovations in material science, opens up exciting possibilities. Researchers are developing new types of glass with enhanced properties. Self-cleaning glass, using nanotechnology to repel dirt and water, could revolutionize building design. Flexible glass, thin and bendable, could lead to shatterproof screens for electronic devices. And in a world increasingly concerned with sustainability, glass offers significant advantages. It's 100% recyclable, meaning it can be melted down and reused indefinitely without any loss of quality. This makes it a crucial part of a circular economy, reducing waste and our reliance on finite resources. The future of glass is bright, filled with possibilities as diverse as the material itself.